Hello everyone, welcome to this vlog. My name is Satya. This is the 9th installation of Simple Home Network Setup series. So as part of this vlog, I'll be talking about network address translation, which is called as NAT in short form, right? So what is NAT? NAT is called as network address translation, but why it is used? So everybody knows that IPv4 addresses are 32-bit long. So 2 to the power of 32 will result in a value or the number of IP address which are not sufficient for all the devices in the world, right? So if everybody gets a public IP, then we'll run out of IP address, or we would have run out of IP addresses by now, right? IPv4 addresses. So for that, the solution is to move the network to IPv6, which is having 128-bit long address, which is 2 to the power of 128, which is a really long number of huge number of IP addresses, IPv6 addresses. So there you won't have the problem of IP address shortage very soon, right? But to convert all the chips, network cards in the network into IPv6 capable, it will take long time. So there has to be a time for transition, right? So to avoid that IPv4 depletion, we use a technology called as network address translation, where we give different private IP addresses on the LAN side and one or more public IPs on the WAN side, right? What I mean to say is, these private addresses which are given on the residential router, I will add the residential router diagram, or I can show you here. So whichever diagram that I've highlighted, that is the diagram or the router with the antennas, it is called as residential router. This residential router translates the packets from private address to a public address, public IP address. So if this technology is not there, then each host on the LAN side will get a separate public address, and then your IPv4 depletion will be reached soon, or very early it will be reached. To avoid that, we have 192.168.129.14, which is private address, which is not pingable or reachable from the outside network from these ISP backbone. So here on this link, which is the IPOE WAN link, we'll get a separate public IP address, right? So this is why NAT is used. Now the other question is, what are the different types of implementations in NAT, or what are the different types of NATs that we have? The first one is static NAT, where we have a single private IP address and a one-to-one mapping with the public IP address. Then what is the difference, right? So if you have one-to-one mapping between a private IP address and public IP address, then your IPv4 depletion will also be reached sooner, right? Because there is a one-to-one mapping. Each private IP address has a unique public IP address, so scaling of IPv4 address is not possible, and IPv4 depletion will be reached soon, right? So this is not a commercial use case. Static NAT. Dynamic NAT. So dynamic NAT is a situation where a public IP is chosen from a pool of public IPs. So each residential router will be given a pool of public IP addresses by your ISP backbone router. So from that public IP address, randomly it will give, or sporadically it will give, translate the private address to the public IP address. So there is no one-to-one mapping, but there is many-to-many mapping for sure, right? The private address will be mapped to one of the public IPs in the pool, so every time it may change, right? So that's why it's called as dynamic NAT. This is also not scalable, as we have pool of public IP addresses. So since we have pool of public IP addresses, we need more than one public IP addresses on the WAN side, which is not a scalable solution, or IPv4 depletion might be seen here if you adopt it. What is port address translation? Port address translation, multiple private IPs mapped to a same public IP. So there will be a same public IP for each and every private IP, right? But only the port is changed. That's why it's called as port address translation. If you visit or view my previous vlogs, I've talked about transport layer. The transport layer port will be changed, whether it's TCP or UDP, the port will be changed in case of port address translation, right? So what is NAPT? NAPT and port address translation is used in home networks. Most of the home networks have port address translation being implemented. What is network address port translation? In this NAPT or network address port translation, both your address IP address and the port are translated, right? So this is also not a scalable solution. It is used in one of the carrier grade NATs where we don't have many private IP addresses, right? So depending upon the use cases, it is much more made restricted, right? Restriction level is adapted much more, right? These are the static NAT, dynamic NAT, port address translation, network address port translation. These are the generic NAT types, but these can be categorized more in depth by applying more restrictions per port or per IP. So let's see what are those restrictions. One of them is full cone NAT. What is full cone NAT? Each port is mapped to one particular port. So once you send that, a private address is mapped to a public IP address, and this public IP address uses one particular port, then anybody in the network, in the public network, in ISP backbone, can send to that particular IP address. It is very much used in gaming solution, right, where one PC is adapted for full cone NAT, right? So I will repeat again. In full cone NAT, each IP is transferred to a public IP, which is a single public IP for all the private IPs. But the port, once you translate it, that port and that IP combination can be reached from anybody in the backbone network, right? There is no restriction as such. Once that port is open, anybody else can also send to that port easily. So there is a threat of attack easily, because ISP backbone network might have hackers also, right? In private network there may not be hackers, but in public ISP network there will be lot of unwanted people like hackers who will hack your device, right? So using different technologies, they may just have to know your IP address and port, and they can send. So the residential router, home router, the NAT router will not restrict it. So to avoid that, we have restricted cone NAT. In restricted cone NAT, it restricts access. For example, a private IP is contacting a public IP in ISP network. The private IP on home router, source private IP, is translated to public IP. Once that public IP reaches one destination public IP, only that destination public IP can send packets to it. That means to say that if you know from your browser window, if you have contacted a particular URL mapped to a particular IP address, then only that IP address can send packets to you. No other IP address can send it in the ISP backbone. So attacking or spoofing or hackers cannot use or leverage this restricted cone facility, because where there is restriction on the people who can access or send packets to you behind the NAT. Port restricted cone also restricts the access by port. So each source public IP is translated to each source private IP is translated to a source public IP, and this source public IP contacts a one public IP. But at the transport layer also, one port will contact another port on the ISP router application. Only that port IP combination can contact or send packets to the private IPs in behind the NAT. So this is much more restricted. That is, port also is restricted. In symmetric cone NAT, each access, that is each private IP, when it opens a URL, like for example www.google.com or www.facebook.com, both of them will result in one public destination IP, two public destination IPs. So each source private IP will be mapped to a separate public IPs on the NAT side towards public ISP network, where separate public IPs are used to access google.com, and separate public IP and port is used for facebook.com also. So each time you establish, for example, you open two windows, right? One is facebook.com and other window is also facebook.com. Even though both URLs are same, each time there will be a separate public IP that will be source public IP will be given. So this is very secure, right? So hackers cannot utilize this to hack your device, right? So friends, this is what I wanted to discuss. If you like this video and want to know more about network address translation topic, do subscribe to this channel and mention in comment that we want to know more about it. I will add more information in the next vlog. Okay, thank you, bye.